Welcome you all to this tutorial face detection with Python using OpenCV. So today agenda is I give you some introduction about what is maybe object detection and then computer vision. Then we'll move on to see the difference between computer vision and image processing, and then introduction to OpenCV, and then some basic image processing operations using OpenCV. Then finally we're going to see face detection using OpenCV. So the first thing is object detection. Object detection is a computer technology related to computer vision and image processing that detects and defines objects such as humans, buildings, and cars from digital images and videos. This technology has the power to classify one or more objects within digital images. Object detection has been around for years, but in recent years it's becoming more popular in industries. For example, consider two images shown below with object in foreground. There is a bird in the left image while there is a dog and person in a right image. Solving the object detection problem means placing a tight bounding box around these objects and associating the correct object category with each bounding box. How object detection is currently being used in industries. There are several use cases ranging from personal security to productivity. Facial detection is one form of it, which can be utilized as a security measures to let only certain peoples into highly classified area. So with this, I think now it is clear about object detection. Let's move on to the next slide. Computer vision. So computer vision system aims to replicate human visions using computers. Such system can help computers in learning and taking actions based on visual data. For this, computer vision uses artificial intelligence and machine learning. Computer vision can find patterns in images. Also, such system can spot and sort different types of objects. Computer vision takes images and videos as input and gives information such as size, shape, and color as output. This system uses camera and sensor to collect input. With these devices, computer vision can study images and videos to produce results in real time. These systems are used for helping autonomous cars in driving. Self-driving vehicles can spot objects such as light poles, pedestrians, and other vehicles with computer vision. This system can create a 3D models for road and predict crashes. So when humans look at the image or video, we can recognize and locate objects of interest within a matter of moments. The goal of computer vision is to replicate this intelligence using computers. So I think computer vision is clear right now. So let's move on to the next slide. So here we're going to see the difference between image processing and computer vision. So image processing applies mathematical function to images. The outcome of image processing may or may not provide detailed data. Hence, image processing does not require machine learning. Instead, image processing perform operations such as sharpening, smoothing, stretching, and contrasting an image. Computer perceives images as 2D signal that consist of rows and columns of pixels. The input taken by image processing system can provide useful data in many applications. For example, hospitals use image processing in biomedical images like a CT scan, ultrasound, and MRI. With this, doctor can obtain important data about their patients. Such data helps doctor in confirming their diagnosis and deciding a suitable treatment. Also, image processing is used in every smartphones. After clicking a picture, the smartphone uses image processing algorithm to generate visually appealing pictures. Here the algorithm adjusts contrast, highlights, shadows, and many other properties of an image. So, computer vision. I believe all you are in Facebook, and the moment you upload any kind of picture on Facebook, there is a feature called auto tag. Facebook will give you suggestion to tag people who are there in an image. So how do you think that happens? That happens all because of computer vision. So computer vision that deals with how computer can be made to gain high level understanding from digital images and videos. So idea is to automate tasks that the human visual system can do. So computer should be able to recognize that this is a face of a human being, and this is what a bus looks like, and this is basically a car. So things like that. So the next thing is how computer reads an image actually. So the normal human can easily tell that there is a building in an image. But can computer really see this? Well, the answer is no. Computer sees a matrix of numbers between 0 to 255. So the colored image, firstly there is a three channel red, green and blue. And there will be a matrix associated with each of these channels, and each element of this matrix represents the intensity of brightness of that pixel. All of these channels will have a separate matrix, and this will be stacked onto each other to create a three-dimension matrix. So computer will interpret the colored image as a 3D matrix, and I hope is clear about it. So when I say that the size of an image is 600 cross 600, it is a colored image. It means there are 600 rows and 600 columns, and there are three channels because it's a colored image. So if it is a colored image means we'll be having three channels, red, green, and blue. And if it is a grayscale image means we'll be having a single channel. Okay, and so the computer reads an image like this in the form of a matrix, and it consists of three channels. If it is a colored image, and if it is a grayscale image, it will be having a single channel. And then the size of the image can be calculated by a number of rows and number of columns and number of channels. Okay, so here the B stands for number of rows, and A stands for number of columns, and 3 means it indicates it's a colored image. So the next thing is what is OpenCV? OpenCV essentially stands for Open Source Computer Vision Library. OpenCV is a library of programming function mainly aimed at real-time computer vision. It is used to do all the operations related to images and videos. In OpenCV, all the images are converted from or to NumPy arrays. So there is any image that OpenCV first converted it into a NumPy array. That's how OpenCV will work. Since we saw the computer will first convert the images into matrix, and this case it will convert the into NumPy array or a matrix. So the example is read and write an image, detection of faces and its features, detection of shapes like a circle, rectangle, etc. Text recognition in image, modifying image quality and colors, developing augmented reality app. The next one is so let's start implementing some basic operations using OpenCV. So the first thing we're going to do is we're going to install OpenCV. Okay, so using pip install OpenCV-Python, we're going to install OpenCV, and then we're going to import some necessary library files like a NumPy array. Since images will be converted into NumPy array, we need a package NumPy, and then CV2 stands for an OpenCV, and matplotlib is an data visualization package. To display an image, we'll be using this matplotlib. Okay, so then to read the image, we'll be using imread function, and then into the bracket we need to mention the image name along with the extension, and then I'm going to use Google Colab. Okay, Colaboratory. So Colaboratory is a Google product. Anyone with a Gmail account can able to use this feature, and in a Google Colaboratory, it won't support IM show directly. So for that, I'll be including one more line. Say from google.colab patches import cv2 underscore IM show, and then using the im show command we can able to display the image, and then to save the image we'll be using im read and then a new file name comma the old file name. Okay, so let's try it in the Google Colab. So first of all open your Gmail drive. So here you'll be having an option called my drive. So in that my drive, go for a more option, and then go for a connect more apps. So it will pop up with a lot of applications. So here what we're going to do is we're going to search for Google Collaboratory. Okay, Collaboratory. So just type Collaboratory and then search for it. So since I have already installed it, it's showing me as an installed. If you want to install, it will give option for installation. Just click it. It will take some minimum amount of time, and then once installation is over, you will be getting Google Collaboratory extension over here. Okay, just click it. You'll be opening a notebook, which is similar to Jupyter Notebook. I think everyone knows very well about Jupyter Notebook. So it looks similar to Jupyter Notebook. It takes some time. 3 minutes is slow. Yeah, fine. I got it. So, so here you're going to type the lines of code. After completion of code, just click this play button. It will run the cell and give you the output for the particular line. Okay, line or set of statements. So first thing what I'm going to do is I'm going to install OpenCV. Okay, to install OpenCV, we're going to use a command called a pip install, and then OpenCV hyphen Python. Okay, so done. Just click the run button. So one more thing, the internet connection should be faster so that it will be executed as soon as possible. Okay, okay, that's a small mistake. I made a spelling mistake in install. Okay, yeah, now I know it's clear. Yeah, I'm done. So since I have already installed OpenCV, it shows like requirement already satisfied. Otherwise, it will take some time to download and package and install it. Okay, so go for the code. So it will create a new cell. In this cell, I'm going to import some necessary packages. Say import numpy as np, and then import cv2. It's an OpenCV thing, and then import matplotlib dot py plot as PLT. Okay, so it's an data visualization package. To display image, we'll be using matplotlib. Okay, so run the cell. After that, create a new cell, and here what I'm going to do is I'm going to use imread function to import the image. So before typing this line, first thing I need to import the images, necessary images into the currently working directory. So for that, you will be having a option called files on the left side toolbox. Click it, and then here we'll be having an option called upload. Click the upload, and then I already downloaded some images. Okay, I'll take image and then 0. Okay, I take two images, image as well as image 0. Open it. So it will ask for a reminder upload files will get deleted when the runtime is recycled. That is, once you close this window, the notebook, the files which you have uploaded will be deleted. That is images, and then what are the supporting data set you have uploaded will be deleted. So click on OK. Okay. So I'll use as image CLO color equal to use the colored image. So image color equal to cv2.imread. Inside the bracket, I need to mention the image name img.jpg. Okay, so run it, and if it is any having any errors, it will show. So there is no error. So create one more cell, and then what I'm going to do is I'm going to use okay, first I'll show you how to display it using a matplotlib. Okay, so plt.imshow, and then inside the bracket I need to mention the image name, that is imgcolor color. Okay, that. So click the run button. You'll be getting an image with some difference in color. Yeah. So the original image. So this is the original image, and yeah, this is the original image, and this is the image which we got using data visualization tool Matplotlib. So there is a small color variations because usually the OpenCV will have a pattern called BGR, okay, blue, green, and red, whereas the Matplotlib will have a pattern RGB, the red, green, blue. Okay, so to avoid these issues, we will transform the channel to how Matplotlib expects it to be. Okay, using a function called CVT color. Okay, so using a CVT color function, we can able to uh, avoid this type of issues. Okay, so I'll show you how to do it. So I'll take image change. Okay, I have changed it somewhere else. Okay, image change equal to cv2 dot cvt color. So it should be in a caps, and then inside the bracket I need to mention the image color which I've already loaded over here, comma, and then cv2 dot color. Everything should be in a caps, underscore, and then we need to convert it from BGR, blue, green, red, to RGB. Okay, so I think now it's fine. Okay, I've done it. So there is no error. So what will happen is then I'll print the using. I'm going to display the image using imshow function. Sorry, that plot dot imshow. Inside the bracket, I need to display the image change. Okay, after the conversion, it will be stored in the object called image change. So I'm going to print the image change object using imshow. So right now I'll be getting exact image without any color variations. So it will take some time. Yeah, so right now I'm getting the exact image which I have uploaded. Okay, so here what the thing is, the matplotlib will follow the pattern RGB, whereas OpenCV follow the pattern BGR. So there will be small color variations in original image which I have uploaded, and the image I have displayed using imshow function. So to overcome these issues, we'll be using a function called CVT color to convert it from a BGR format to RGB format. Okay. Um, so the next thing is what I'm going to do is so I'll show you how to display it using a direct polar function. I am show. Okay. So for that I need to include one more thing from Google dot Colab Google Colab dot patches import cv2 underscore imshow. Okay, so if you are using any other tools like Jupyter Notebook using Anaconda, You can directly use the cv2.imshow, but since I'm using a Google Colab, it will not support cv2.imshow directly. So instead of that, I'll be including importing some function cv2 underscore imshow function from the Google patch. Okay, so after this, import it. So it's showing some error from google.colab. Everything is fine. Yeah, form. No, 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 no. So mistake from Google Colab. Okay, so now it is imported, and I'm going to use a cv2 underscore imshow. Inside bracket, I need to mention the image which I got it initially, which I loaded initially. Okay, you can check it over there. This is the original image which I have uploaded first. That is the image.color. And once I display it using imshow function with the help of a matplotlib, I have a color variations. So here I'm going to display the same image with cv2 underscore imshow function. So let's see what happened. Since the image size is somewhat bigger, I took it as 1200 cross 1200 size image. So it will take some time. Yeah, I got it. Okay, so I think now we got an exact image which I have uploaded 1200 cross 1200 set image. Fine. Okay, so okay, let's go back to the slide. So here you can see, yeah. So I have shown you how to install OpenCV and then import some necessary library files like NumPy and then OpenCV and then matplotlib for data visualization, and then using imread, how we're going to import the images into a Google Core laboratory, and then using imshow function directly we can able to display the image. Apart from that, using matplotlib also we can able to display the image, and we'll be having some small color variations over there. To overcome those color variations, we'll be using cv2 function. So everything I have shown in notebook. So right now, the next slide, we're going to see some basic operations on images using OpenCV. So the basic operations like type usually the image type will be in a NumPy array. I already told you that once you upload the images into an system, that is a computer, it will be stored in the form of matrix. Okay, so here it will be in the form of NumPy array or NumPy matrix, and then shape. So shape indicates a number of pixels. So the image which I have already uploaded is 1200 cross 1200 with three channels. Okay, so it is a colored image, so it should be a three channels RGB. And if it is a grayscale image, means it will have a single channel. So the next thing is D type. The data type of an image is uint8. That is a 8-bit unsigned integer. The numbers from 0 to 255 as indicated by D type. Okay. So and the maximum minimum number in the matrix can be checked using the min and max function. So then the size, that is the total number of pixels, can be obtained by using the function called size. Okay. So let's try all those functions in a notebook. Let's open it and then just go on it. Okay, and then create a new cell. The first thing is type. So type and then image color. Okay, so this is an object. I have stored the image. So it will show me as a numpy array. Okay, so the next thing is I'm going to find the shape. So image color dot shape. So it will give me the shape of the image, that is 1200 cross 1200 with the three channels. Since it is an So since it is in a colored image, it will give me as 3 RGB, okay, 3 channel, and the size of image is 1200 cross 1200. That means 1200 rows and 1200 columns. Okay. So the next thing is we're going to see the D type. Okay. So image color dot D type. So it will give me as uint8. So it will give me as a uint8, the 8-bit unsigned integer. Okay, and to find the minimum and the maximum values in the matrix, we're going to use a function called a min and max. So image color dot min. So it will give me 0. Image color dot. Okay, it is not an image color. Img. Okay, img color dot min. So it will give us the value 0. It is a minimum value in the array, sorry, in the matrix. So the next one is maximum value img color dot max. So surely it will be giving us 255 since it is a colored image. We'll be getting a maximum value as 255, and then finally we're going to check the size of the image. So image color dot size. So it will give us the size of an image. Okay, so already I gave us 1200 plus 1200 with the 3 channel means it will multiply all those values, and then it will give us size means so it will give us the entire size of an image, that is this value. Okay, so the next thing is just go back to our slide, and then okay, so till now we have found some basic operations using images in an OpenCV. And then the next slide is basic image processing operations. So convert a colored image to a grayscale image. We already seen about the CVT color function to convert from a BGR to RGB function. So the same function can be used to convert the colored image to a grayscale image, and converting image to grayscale with an IMRate function. Using the IMRate function also, we can directly change the colored image into the grayscale image. We're going to see those two type of methods, and then we'll see how to make some smoothing in an image using a Gaussian blur, and then Gaussian blur function, and then blending of two images. That means adding two images, that is the compressing of two images using a add weighted function. Okay, so we're going to see how to convert the grayscale image into an sorry, how to convert the colored image into the grayscale image using IMRate function directly, as well as in the CVT color function, and then smoothing an image using the OpenCV Gaussian blur function, and then a blending of two images using added weight function. Okay, so in a Gaussian blur, we'll be having here the DST stands for a destination, and then CRC stands for, sorry, SRC stands for source, and then K size stands for Gaussian kernel size. Okay, height and width, and the height and width should be odd and can have different values. If the K size is set to 0, then K size is computed from a sigma value. Okay, so the sigma x and sigma y is a kernel standard deviation along x-axis and y-axis respectively, and border type specifies image boundaries, while the kernel is applied on image borders. Okay, possible values are border underscore constant, border underscore replicate, border underscore reflect, border underscore wrap, and then border underscore default, isolate. We'll be having this much of options over there, and then for a blending two images, we'll be having a SRC, that is an image one, and then source image one and source image two, and then alpha and beta are the corresponding weights to be considered while performing the weighted addition. That means how much variation should be there between image one and image two will be denoted by alpha and beta, and then gamma stands for static weight that will be added to all the pixel of an images. Okay, so let's try all those functions in notebook. Okay, so first thing what you're going to do is we're going to convert a colored image into grayscale image using a CVT color function. Otherwise, we can able to use a direct IMRead function to change it. Okay. So first, I'll show you how to directly do it using a IMRead function. Okay. So image gray, okay, equal to CV2 dot IMRead. Inside the bracket, I'm going to mention the image name img dot jpeg inside the quotes, and then comma. I have to mention it as 1. So 1 means it is a grayscale image. So let's print and see that using cv2 underscore imshow function. I'm going to print img gray. Okay, so it is in a grayscale image. So I can able to directly get the colored image into a grayscale image. It is not showing me. Sorry, I need to mention it as 0. So if it is in 0 means it is a grayscale image, and if it is a 1 means it is a colored image. Okay. If I are getting the image, if you're going to import the image using IMRead function, if I mention it as 1 means it will give us a colored image, and if I mention it as 0, then it will be giving me as an grayscale image. Okay, now I have mentioned it as 1, so it will be giving a colored image. So if I mention it as 0, it will give me a grayscale image. Fine. So you can see that we have obtained a grayscale image. During import, while importing the file itself, we can able to change the scale of the image, grayscale or a colored image. Okay. So we can able to do it with the help of CV2 function, which I've already told you. So I just create one object gray equal to cv2 dot cvt color. It should be in the caps, and then inside the bracket I need to mention the old image name. It is in img color, and then comma. I need to mention cv2 dot color. Everything should be in the caps. Underscore. I need to convert it from it is the img color image in this in the form of bgr. Okay, so bgr format to I need to convert it into the grayscale. Gray. Okay, so and then in the same cell I'm going to use cv2 underscore imshow function to display the image. So, okay, so around the function on the cell I'll be getting a grayscale image. Okay, so img color, the img color image which have loaded a colored image. Okay, you can check it at the beginning of the thing. img color is an okay, img color is an colored image, and I can going to convert it into the form of a grayscale image with the help of cvt function, cvt color function. So the next thing we're going to see is how to make some smoothing using Gaussian blur function. Okay, so smoothing an image. Images also can obtain different types of noises, especially because of the source, that is the camera sensor. Image smoothing technique help in reducing the noise. In OpenCV, image smoothing, also called blurring, could be done in many ways. In this tutorial, we're going to see the Gaussian blur, okay, Gaussian filter of a image smoothing. Okay, so just what I'm going to do is I'm going to create an object dst equal to um, cv2 dot imread. Inside the bracket I need to mention the path, that is I already have uploaded the image, so I can directly blur it. Okay, so what I'm going to do is I'm going to create one function dst as a destination equal to cv2 dot Gaussian blur. Inside the bracket I need to mention the source image. Source image is img color. Img color is a source image, comma. I need to mention the that is in a k size. Okay, k size value, and I already told you that the k size value should be in the form of odd, and then it is in a height and width, it should be in the form of odd. Can have a different values. If a k size is set to 0, 0, then a k size is computed from sigma values. Okay. So the next thing is I'm going to cv2 border default. cv2 dot everything should be in a cap. So border underscore default. So it is in a border type. Specifies the image boundaries while kernel is applied on image borders. Okay. Possible values are, I already told you that border underscore constant, border underscore default, border underscore isolate, and reflect, and then wrap. Everything will be there. So I'm going to use border underscore default. That is in a default image will be given over there. And then I'm going to use imshow function to print it. So cv2 underscore imshow to display the blurred image. Okay. So here the what I'm going to do is I'm going to use something called edge stack. Edge stack is so imshow, and then I'm going to use a numpy array dot edge stack. So inside it, I'm going to use image color, comma dst. So what it will do is it will display the images in the column wise. Okay. It's trying to take one position only, but two were given. Dot edge stack, and then image color dot dst. It's like this showing in numpy dot edge stack dot dst. Two were given. Okay, since underscore. Okay, fine. If one position only, the two were given. Okay, fine. Just use show function and directly print the dst. So it will show me the blurred image. So you can see the image is somewhat blurred. So if you want to increase it, increase the smoothing value, you can mention it over here. And one more thing, it should be in the form of odd numbers only. You should use only the odd numbers. Okay. So right now it's clear that smoothing I have done. So we just go and have another thing that is called. So we're going to blend. We're going to add two images using a add weight function, blending of two images. So here we're going to use one more function dst, that's the destination one equal to cv dot add add weight add weighted, and then the source image one, that is in first image which I'm going to blur img, and then comma 0 0.5 for the first image, and then img 0 img 0 comma 0 0.5 for the second image, and then constant weight which will be added for each and every pixel will be mentioned over here. Here I mentioned it as 0 0.0. Okay, so before that I need to import the second image. So till now I've used only a single image. So I'm going to import one more image, that is img0. Okay, so for that I'll be using a cv2.imread. Inside the bracket I'll be mentioned as img0.jpeg within a quotes. Fine. So I'll run it. Okay. So, I'm going to store it in the object img0. Okay. So I'll run it. And right now the object, the second object img0 is stored into the object img0, and then I've used an add weighted function, and img is an source image 1, and then I'm going to set 0 0.5 as an alpha value, and source image 2 will be an img0, and for a beta value I set it as 0 0.5, and for gamma value it was 0 0.0. So the alpha and beta are corresponding weights to be considered while performing the weighted addition, and gamma is a static weight that is added to all the pixels of the images. Okay, so I just run it. They're showing some errors. CV is not defined. Sorry, it was CV2. Okay. Image was color. Okay. Image color. Now it is fine. So have a one more cell, and then I'm going to display using CV2 underscore IM show, and then into the bracket I need to use DST1. Okay. So run it, and we can see the image is blended. That is, two images are merged into single. Okay. So if you increase these values, it will be more highlighted. Okay. If you want to highlight an image one, that is an IFG color, if I use 0.2, let's see what will happen. And then run the intro function. Okay. So the if you use a 0.2 for a first image, the second image will be highlighted more. Okay. So if I use 0.8, then see the image 0 will be highlighted more when compared with an image color. That is the first image. Okay, fine. So thing is now it is clear. We have seen some basic operations using OpenCV in image processing operations, as well as how to read the image, how to display the image using IMShow function, CVT color to convert the images. So now we'll go more to the slides. Okay, so we have done everything. Type, crossing blur. So next thing is in phase detection. Okay, so phase detection is a technique that identifies or locates human faces in a digital images. A typical example of a face detection occurs when we take photographs through our smartphones and it instantly detects the faces in picture. So face detection is different from a face recognition. Face detection detects merely the presence of face in an image, while face recognition involves identifying whose face it is. Okay, so it will tell who it was. Okay, so face detection is performed by using a classifiers. Your classifier is essentially an algorithm that decides whether a given image is a positive or negative. So here the positive means the face is present, and the negative means it is not a face. Okay. So classifier need to be trained on thousands of images with or without faces. Okay. Fortunately, OpenCV already have two pre-trained face detection classifier, each which can be rapidly be used in a program. Okay. So the two classifiers are Haar classifier and local binary pattern. Okay. So in this tutorial, we're going to see about Haar feature-based Cascade classifier. So Haar Cascade classifier employs a machine learning approach for visual object detection, which is capable of processing images extremely faster and achieving high detection rate. This can be attributed to three main reasons. Our classifier employs an integral image concept, which allows the feature used by the detector to be computed very quickly. The learning algorithm is based on ADA boost. It selects a small number of important features from a large set and gives highly efficient classifier. More complex classifiers are combined to form a cascade, which discard any non-phase regions in the image, thereby spending more computation on a promising objects like regions. Okay, so this is how the phase detection with the OpenCV will work. So for the face detection, first thing you need is an image. Okay, so that contains a face, and then a cascade classifier that contains the features of the face, so that your code can determine where is the face actually is present. Okay, so then in the step two, we can OpenCV that will read the image and feature file and then convert it into NumPy array. It will search for the row and column values of the face and display it with the rectangle face box. Okay, so I'll repeat it once again. For a face detection, first thing you need is an image that contains a face, and then a cascade classifier that contains the features of the face, so that your code can determine where is the face actually in the image. Okay, so then in the step two, we can use the OpenCV that will read the image and the feature files and then convert it into NumPy array. It will search for a row and column values of the face and display it with a rectangular face box. Okay, so let's go and implement. Let's go and implement the face detection using OpenCV. Okay, go to your Google Colab. So before that, I'll give you. I'm going to show one more thing. Thing is how the Haas cascade classifier will be working. Okay, so the first thing is I'm going to import CV2, which I already told you how to import CV2. Using Cryptcannon, we're going to install OpenCV and then import CV2, that is an OpenCV, and then read a colored image using CV2.imRead function directly, since it is mentioned as what it is a colored image, and then to convert it into the grayscale image, we'll be using 0 over here. And then since we are using Google Collaboratory, it will not support IMShow function directly. So we need to have one more line, that is a google.colab that patches import cv2.imshow function. And using this cv2.imshow function, we can able to display the images And then next thing is creating a cascade classifier object. Okay, so cascade classifier object means so first we read the cascade classifier by specifying the path of an Haar cascade classifier XML file. Okay, so I already told you that the Haar cascade classifier is a inbuilt function available in an OpenCV. So the XML file will be available. You just download the XML file. I'll give you the link for it in the description, and then just import it using a cascade classifier function, and it will be used in an object called a face underscore cascade. Okay. So after that, what I'm going to use is search for the coordinates of the images. So next thing is we're going to use detect multiscale is used to find where is the face present in a given grayscale image. Okay, so we can't able to use the colored image directly. So we're going to convert the colored image into grayscale image, and we're going to work all those things using the grayscale image only. And using the detect multiscale function, we can able to detect multiscale. It's a method. Using this method, we can able to um, find where the face is actually present in the grayscale image. Actually, multiscale is a method that search for a rectangle coordinates where the face is present, and we have something called the scale factor value. So the scale factor value decrease the shape value by 5% until the face is found. Smaller this value, the greater the accuracy. So your model has a fixed size defined during training. This means that the size of a face is detected in the image if occurring. However, by rescaling the input image, you can resize a large face towards a smaller one, making it detectable for algorithm. Using a small step for resizing, for example, 1.05, which means you reduce the size by 5%. You increase the chance of matching size with the model for detection is found. Okay, so the next thing is min neighbor. So parameter specifying how many neighbors each candidate rectangle should have to retain it. Okay. So and then we'll be having for loop over here. So it is used to create a rectangle box around the face. Okay. So here the first thing is the image, that is which image we're going to use, and then a start point, and then a end point, and then a color, the box color we can mention it over here, and then a thickness will be mentioned over here. Okay, you can mention the thickness over here. So let's go on to notebook, and then we just do the face detection over here. Okay, so the first thing is we're going to import the image using imread function. So I'll take one image img equal to cv2 dot imread, and then I'll import one new image over here. Okay, so I'll import no image. It's a Google Sundar picture. So using the double quotes is okay, dot jpeg. Okay. So right now I imported a new image with a face in the image, and then what I'm going to do is um, I'm going to convert it into the form of grayscale. Okay, so since it is in the colored format, I'll take one more thing. Okay, I take img1 equal to cv2 dot imread image name dot jpeg followed by, since it is in a grayscale image, I'll be giving us 0. Okay, so the colored image will be stored in the object img, and then a grayscale image will be stored in the object img1. Okay, so next thing we just display and see the changes over there. So okay, so I'll be using a cv2 underscore im show. Firstly, I'll display the colored image. Then I'll display the grayscale image cv2 underscore imshow inside bracket img1. So it will give me a grayscale image. Fine. So I have uploaded a colored image as well as a grayscale image. I converted it into the grayscale image. And then what I'm going to use, I'm going to create the, I want to import the Haar Cascade classifier XML file. So before that, I need to upload the file. Okay, this is a Haar Cascade classifier XML file for a face detection, frontal face detection. Okay, so use face underscore cascade equal to cv2 dot cascade classifier, and then into the bracket I'll be mentioning the name of the file. Just copy it and then paste it over here with the extension .xml. Okay, so right now I'm going to import the frontal face Haar Cascade XML file into the face underscore cascade object. So and then what I'm going to do is I'm going to use the cascade classifier, and then I'm going to use the detect multi-scale function to find the rectangle coordinates. Okay, so what I'm going to do is face equal to face underscore cascade dot detect multi-scale, and into the bracket I need to mention the grayscale image. Okay, so image 1 comma scale factor equal to 1.05, and then min neighbors equal to 3. So just run it, and then what I'm going to do is I'm going to use a for loop to create the rectangles box around the face. So for that, for x comma y coordinates with the weight, width and height, that is w and h stands for width and height in faces. Okay, and then use image 1 equal to cv2 dot cv2 dot cv2 dot rectangle. Inside the bracket I need to mention the source image 1 comma coordinates x and comma y, and then comma x plus width comma y plus height comma I need to mention the color 0 comma 255 comma 0. Then I need to mention the thickness of the box. Okay, after that I'll be using imshow function cv2 underscore imshow function to display the image. So you can see that the face is detected in the grayscale image, and if you want to do it for the colored image also, we can do it using img. So here I mentioned as a grayscale image img1. So instead of that, if you mentioned as a colored image also, we can able to figure out the face present in the colored image. Okay. So for that, I need to rerun all these cells. So I have loaded the colored image for the faces, and then for the for loop, I need to, yeah. So right now, you can see that the face is directed in the image, and here you can able to change the color of the box also. So you can mention 0, and you can mention 255. So red, green, and blue. Okay. So if you mention 255 at the last means it will be shown in the blue color. Well, since I'm using CV2, OpenCV, it was a BGR format. So blue, green, and red. Okay. And then thickness of the box, you can mention it over here. Like you can mention 7. So the thickness will be increased. Let it take much time to run. Yeah, the thickness of a box is increased since I mentioned it as a 7. Okay, so this for loop is to create the rectangle box around the face, and then face cascade detect multiscale is used to detect the coordinates in the grayscale image. Okay, grayscale, or you can use a colored image. So it will find where the face present in the given image, and then scale factor. So scale factor means it will decrease the shape value by 5% until the face is found. Okay, and then min neighbor means the parameter specifying how many neighbor each candidate rectangle should have to retain it. Okay, so with this we'll come up with the end of this tutorial. So thank you for watching, and if you have any queries, leave it in the comment section. I will get back to you soon. Once again, thanks everyone for valuable support. In the next video, I'll show you how to create your own Haar Cascade classifier. Okay, thank you.